Hello, everybody. Can you hear me? Yes, I can hear myself. So thank you for making it to my talk. This is very nice. And thank you for droidcon for doing all of this. All right, so my name is Rish, and I'm going to be speaking about Android Wi-Fi under the hood. So what we're going to do is, us developers usually just like looking at the Wi-Fi, looking at the APIs, and using those through which we then build apps. I'm going to try to peel open that a little bit and look what's really inside. So that's what this talk is about. My journey with Android Wi-Fi began 6 years ago with Android Auto. So 6 years ago, I joined this company called Google. And I've been there ever since, working on Android Auto. So I lead the Android Auto connectivity team that works on the car side. Yeah, so that's where then it's, for those of you that don't know what Android Auto is, it's basically you connect your phone to the car via USB or Bluetooth and Wi-Fi, and you get your music and maps from your phone onto your car screen. So it's kind of like CarPlay also, if you've heard of that, but we're at an Android conference. So yes, and so it's been connectivity throughout, and that's where then it's just, you would imagine, after 6 years of connectivity, we would have solved all the bugs that there possibly were, but that's not, we still haven't. And that's then where this talk comes in. So just as a very high level, like I said, your phone, your Android phone, has an app running this app called Android Auto. The car also has an app called Android Auto running on it. Remember, these are both apps, but we're running on, in the car, Android OS. So that's Android Automotive OS. So it's a little bit confusing, but Android Auto is the app. Android Automotive OS is the OS on top of which we're working. All right? And at a very, very high level, the way it works is your phone connects to your car via Wi-Fi. So the big, long story short, your car creates a hotspot, your phone connects to it. It's kind of like how your phone connects to your home router. Now, at this point, this is something that gets interesting to me, which is essentially all the car has to do is call WifiManager.startAccessPoint. That's the TLDR of this whole thing is that's it. But whenever we tried to do this, so if you just call the API and you expect it to work as it should, it doesn't always do that. And even if you as a developer, you see this bug, say you see this bug that happens like 1 in 1,000 times. So that's like 0.1%. You see this 1 in 1,000 times, you're like, you're just sitting there rebooting your head unit or your car, and you're waiting, and you're like, this bug really doesn't happen. So 1 in 1,000 times, you're just going to shrug it off, and you're going to be like, this is fine. But now imagine if you have millions of users. That becomes tens of thousands of cars which face that bug. So you as a developer who's just rebooting your car, and you're like, that bug never really shows. It's like 1 in 1,000, But it becomes such a big deal when you're in production. So that's around about where then I realized, all right, we really need to start digging in. And so our journey today is going to be, first of all, we're going to demystify what happens in the Android Wi-Fi stack. We're going to peel open, look inside at the APIs. And finally, I'm going to give you a concrete example of the stuff that we've had to do and the reason that I've had to go into this. I would have just loved for these APIs to just work. But it's also been very interesting, the whole journey going through it. Yeah, so that's what we're going to cover today. OK. Before we begin, I hope you're going to like Wi-Fi as much as I ended up liking Wi-Fi, because there's a whole lot of types of Wi-Fi, really. There's the everyday types that we use, which we all know. You connect your phone to the router. You're connected to the Wi-Fi over here, and that all of us do. And then that means there's also a router on the other side, or an access point. So that is, we basically have Wi-Fi infrastructure, which is called STA, or station mode. So again, remember, these are Wi-Fi concepts that also exist in Android. So you're going to see classes for all of everything that I'm going to speak about. So they're classes in Android, but these are Wi-Fi concepts. So Wi-Fi infrastructure is basically STA. That's also how it's referred in the Android stack. So whenever I speak of STA, it just becomes then common language. It's basically the regular Wi-Fi that you all know. Wi-Fi hotspot, or soft AP, is software access point. That's because it's repurposing the hardware to become a router of its own. So that's why it's like software access point. And that's essentially when your phone becomes an access point for others to connect to. So in this, you have two types. You have the tethered and the local only. So tethered is the one that we're all more familiar with. Whenever you have a friend who never has a data connection or is always running out of internet, they ask you for, give me a tethered hotspot. That's really what they mean. So the tethered hotspot gives you internet. The local only is a little less heard of, but it's very interesting. It gives you connectivity between devices without sharing internet. And so this is useful for, say, games. Or in our case, we also happen to use this in Android Auto. Again, this is configurable by car manufacturers. Some car manufacturers also want to give tethered access points. But for a lot of cars, it's always local-only hotspot. So whenever I say local-only hotspot, that's essentially an access point hotspot. They're all the same words for the purpose of this talk. And yeah, we're not providing internet through this hotspot. So that's what this local-only thing is. OK. There are more types, ones that are little less heard of, cousins of Wi-Fi, if I say. So let's start with the first one, Wi-Fi Direct, also called P2P. Again, concept of Wi-Fi also exists a class in the Android's APIs. So Wi-Fi Direct allows you to connect two devices without creating an access point. So it's kind of like Bluetooth. You know how you don't have like a Bluetooth server or like a Bluetooth access point. You connect those two devices. So it's sort of like this. Similarly, you have Wi-Fi Aware, which allows you to discover and talk to other devices without really connecting to them. This is also similar. You know, if you have these weighing scales that are just broadcasting, saying, hey, I'm a weighing scale. So they do this over Bluetooth. That's sort of similar. This allows you to do that thing, but over Wi-Fi. So that's Wi-Fi Aware. Again, there are classes that exist for this. And you really can use them for some of your apps. The one that I find the most interesting is the last one, Wi-Fi RTT, or Wi-Fi round trip time. Essentially what that is your device can calculate the precise distance that it is from another router. So you can use this for basically indoor localization. So if we, for example, had a router here, here, and there, it would very accurately tell you where you are. Of course, there are problems with like the waves bouncing around the walls, but it's very accurate. And you should also try this at home, like just as a free, fun app. If you have a couple of phones, you can really see it measuring that distance. So those are the types of Wi-Fis. These are the lesser heard ones, but also very cool ones. What we have next, and this is an important part that we should get into, is you've probably all heard of this. You've got 2.4 gigahertz, and you've got 5 gigahertz frequencies. So these are frequencies. I will sometimes use the word channels, but frequencies and channels mean the same thing for purposes of this talk. You also have 6 gigahertz that I haven't put up on the slides. That's relatively new. But let's get into it. So 2.4, just think of this as essentially a highway, like literally a highway between your device and the access point. It's like a highway, and all you have for 2.4 is like this old, dusty, 2-lane road going from one side to the other. The benefit is it can be really long. So you can go far distances, but it's only a 2-lane road. So you cannot send out so much data through it. And there's a lot of congestion in this. Why is there congestion? It's because so many devices are using 2.4, but also Bluetooth is on 2.4 gigahertz. So what that means is then there's really contention for, oh shit, there's so much 2.4 going around. So you see more interference. Then there's 5 gigahertz. So that's like a 6-lane road, but it goes shorter distance. So you can send a whole lot more data, but it doesn't go so far. And again, because there's so much space there, there's less radio interference. 6 gigahertz, again, there's like a 12-lane road. You can do so much more, but again, shorter distance. So that's how it is. And the very last in this whole configuration, oh, wait, important. Oh, I wanted to ask a question here. Well, for Android Auto, we're using 5 gigahertz. So essentially, that makes sense, right? You're in a car. The car starts an access point. Your phone connects to it. The phone is always going to be inside the car. So we're using 5 gigahertz for it. That was the question that I wanted to ask. But yes. Then there's a little more over here. And this is the last part of all the types of Wi-Fi and the configurations that we have. With Android 9, essentially what you could do is you could start an access point on your phone and also connect to another access point. So you'd have an access point on your phone and also be connected to Wi-Fi, which in itself is cool. But with then Android 12, you got station mode plus station mode, which means your phone can be connected to 2 Wi-Fis at the same time, which, if you already know this, is like, I know this. If you don't know this, I think that's so cool. Like, my phone doesn't support this. And I don't even know. I think some Samsung phones have this, where you can connect to 2. So that's really cool for me. Another one is access point plus access point. A lot of cars do this. So you have 2 access points started. Usually one is for 2.4 gigahertz, one is for 5 gigahertz. Or one is the tethered access point, one is the local only. The reasoning for this is car manufacturers often want to sell data plans. So they want one which is then selling data, the other not. And lastly, with Android 13, you also have 6 gigahertz. Yep. Cool. Now, armed with all this knowledge, let's go into the Android stack. Before we go into the Android stack, though, we should have a quick brief on the Android software stack. So there's this nice, colorful diagram from the official website. We'll get into the websites in a bit, but this is in developer documentation. So let's break that down. At the very top, you have your system apps, which are, say, Gmail, Settings app, or in our case, the Android Auto app. Right? So those are all the apps, the ones that we often make. Below that is the Android API. So over there, you have the classes that you often call into, like context, Wi-Fi manager, sensor manager, all of those. And alongside those, you have a lot of the native libraries. So OpenGL, Skia, all that stuff goes in over there. And of course, the Android runtime is there. Below this is where it gets, so this is the special part of Android that makes Android Android. And so does this. So the hardware abstraction layer is essentially a very thin layer that Google provides. So Google makes the API saying, hey, we need this from the sensors so that our Java APIs will work. And so what hardware manufacturers do, like say Samsung, Qualcomm, Broadcom, whoever's making the chips or the actual hardware for sensors, they go implement these APIs in the HAL. And oftentimes, so we call these vendors. So that's usually, when I say vendor code, that's what we mean. And this is almost never open source. So this is then proprietary to Qualcomm, for example. And yeah, that's one of the parts of Android is never really open source. Yeah, so we have the hardware abstraction layer. And this is the special layer. It's very thin from Google's side, pretty big from then the vendor's side. Finally, below this, you have the Linux kernel. The Linux kernel is, again, part vendor, and then open source, the kernel that we all know. And then this is the part that's really doing the talking to the hardware beneath. Yeah. So now if we simplify all of this from that big diagram, we're going to come down to just this. So all we have is then applications at the very top, the Android framework beneath it, below that the HAL and the vendor code, and at the very bottom the Linux kernel. All right? And that's then the Android software stack at a very high level. So if you don't know this, now you know. Like, always remember this. It's the same for almost all vertical stacks that you go into. So if you go into the camera stack, if you go into the sensor stack, whichever really, the display as well, they're always going to look very similar. So today we're discussing Wi-Fi, so we're going to go into Wi-Fi. So at the very first, let's go top down. So from the very top, applications, down to framework. So we're going to go 2 ways down. So we've got soft access point, and we've got the station mode. So for soft access point, you're going to call, if you're making an app and you want to start an access point, you're going to call WifiManager. So you usually do that context.get system service, WifiManager. You get the WifiManager, and then you request to start a local-only hotspot. For station mode, which is the normal, regular Wi-Fi that you always use, you use ConnectivityManager. That's the way it evolved over time. There's a whole history. You used to only require WifiManager, and then there were more constraints that we wanted to have, for which then ConnectivityManager was introduced. So the way you do that in code is literally just WifiManager equal the context.get system service. You get the WifiManager. And the important line, remember this line, because this is where it's going to be useful in the concrete example. WifiManager.get.start local-only hotspot. We're going to be using that in a bit. So just remember that all this line does is it requests to start an access point that doesn't share internet. And then for ConnectivityManager, it's similar. You call ConnectivityManager.requestNetwork, the Wi-Fi that you want to connect to. All right. Beneath this is where now it starts getting interesting. Actually, just for a show of hands, could I know how many of you have traversed these stacks for any purpose, not just for Wi-Fi? Oh, OK, a fair number of you. OK, good. So then this is more of a recap for you folks, I suppose. All right. For soft access point, you go from WifiManager down to Wi-Fi service, and then more classes beneath it. For ConnectivityManager, it's connectivity service. And if you draw the pattern, it's basically the same for all classes. So if you have sensor manager, it goes down to sensor service. Camera manager, camera service. Camera is also an interesting one, because that also evolved over time. There was no camera service, and then it was introduced later. But for most stacks, it's always manager, then down to the service. And so what that looks like is your app, let's take the example of WifiManager to start an access point. Your app calls into WifiManager. That then speaks with the Wi-Fi service impl, as it's called. And then Wi-Fi service impl calls into many other classes down there. There's like this active mode warden, soft AP manager, Wi-Fi native, all these classes that we are not exposed as the API, but they all exist down there. The important part here is the binder. Why do we have this binder in between? This is something you're going to see as a pattern almost in every layer of the stack. So whenever you're switching layers, you're going to have a binder communication. Binder, just quickly, is interprocess. You're going to switch from one process to another. So concretely, that is, the first line is Android Auto, the app, requesting to start an access point. Right? And so if you see, this is just a random number. This is the process ID when I made these logs. It was 2658. And that's the app's process ID. The next line is Wi-Fi service. I omitted a whole lot of lines in between. Android logcat is pretty spammy. But the next line is Wi-Fi service, start LOHS, local only hotspot. And there you see this number, which is different. It's 1476. And so that's the system server process. Why is that different? The reason is, if our app crashes, we don't want the whole stack to crash with it, right? So if one rogue app crashes, you don't want like the whole system to come down, which is why we always switch processes. And this happens then down to HAL, then it happens down to kernel. You're going to see all these process switching happening. So when people tell you it's expensive to do IPC, inter-process communication, yes, but also the whole stack's also doing it a whole lot. All right, now, next is, now we've gone from the application down to the framework. We're going to go from the framework down to HAL. So HAL, remember, hardware abstraction layer. I'm going to be cheeky. I'm going to add another one, native daemons. This is very specific to the Wi-Fi stack. So essentially what it is the top layer, the framework layer, is just instructing down, saying this is what we need. The native daemons, they're essentially just C++ code, which is then speaking with the kernel beneath, which is doing more the heavy lifting work. So that's the part which is like it's just a background process which is always running, which knows how to speak to the hardware beneath. So yeah, as a definition, the HAL, like I said, provides a standard interface for the higher layer classes. Beneath it, you've got the vendor implementations of the HAL. So that's whoever is manufacturing these chips, then they implement those. They may also add to the to the native daemons. The native daemons are background processes that handle all the heavy protocol work with the kernel. So that's now, if we put it all together, that's going to look like this. So for the soft access point, you've got WifiManager, then Wi-Fi service, goes down to host APD HAL. Beneath that, you've got host APD. On the station mode side, you've got ConnectivityManager, down to service, down to supplicant HAL, and Wi-Fi con and WPA supplicant. Now, why on earth am I telling you all of this? Like, where are you going to need this? Well, we'll get to that in the example for the concrete example that I come to. But for you, where it's useful is, if you ever have problems with your Wi-Fi stack, always remember this supplicant word. Like, you're not going to know what it is for a whole while, and then you're like, okay, this thing makes sense. So in your logcat, always be filtering with supplicant when you're struggling to connect to Wi-Fi. If you're struggling to start an access point, it's always host APD. And they're pretty verbose, which is really useful. So in the stack, you're always going to find this. And then the magic at the very bottom is the kernel. So this is the part which was really interesting that I didn't know existed. Well, I knew the kernel existed, but the parts that it's handling. So to take a step back, countries set rules on which Wi-Fi frequencies can and cannot be used. What that means is, remember I said frequencies 2.4 gigahertz, 5 gigahertz? Essentially what they look like, they're like 2400, 2405, 2410. But some countries say, hey, we don't like the number 2420, so we're not going to use those. And that changes. Like, there's a whole Wikipedia page on like the history of these numbers and the politics that goes behind this. It's funny that they exist. But every country has their own. So even when you're driving from, say, Germany to France, those numbers are going to change, the ones that are allowed. So yes, every country, remember, every country has regulations on what frequency numbers can be used. The Linux kernel is the one that enforces these regulations. Why? It makes sense. It's the closest thing to hardware. So it's the one that's going to enforce what can and cannot be used. Beneath that, the police officer, the Wi-Fi driver ensures the hardware only operates within those legal limits. But for that, it needs to know which country it's in. How is it going to know which country it's in? It's going to find this out from the Android framework, which for me, when I first found out, I was like, eh. So you have all these regulations which are set only at the very bottom, but you can trick it. You can tell it you're in a different country. And you can. You can literally just run an ADB command, and you can say, we're in US right now. So it's a little iffy, but you would need ADB root for this. So you can only do this if you have root access. But yes, so that's how the Wi-Fi driver down there needs to know which country it's in, which it gets from the framework above. OK, armed with all this knowledge, let's look at the whole graph. Our chart is beautiful. I was really happy when we made these slides. Yeah, so that's the whole stack, and that's what it looks like. Now, all of this information and more, if you don't already know, I would highly, highly recommend. cs.android.com is code search. This is also something we use, I don't know if I'm allowed to say this, internally at Google. It's also called code search. So cs.android.com, the UI looks exactly the same inside. You can essentially traverse the whole stack. But it's very confusing because you go from WifiManager, you look at the calls, and then you go down to Wi-Fi service, and you're like, OK, this makes sense. And then you see some more classes, like that active warden, and then Wi-Fi native, and then you're lost. Because from there, you go to C++ code, and you're like, what? Where'd it go? And that's really hard to find, for which I would really recommend Gemini. I'm not here to do an AI sales pitch, but it's really useful. It really does know the stack, and it will help you. It'll tell you where to look next. So I'd recommend that. And source.android.com is the there's developer.android.com, which is useful for developers to make apps. Similarly, source.android.com is useful for making or understanding the OS down below. The camera manager or the camera stack is so well documented. So if you're just interested out of curiosity, It's a bit deep, but I would really recommend it. Like, I love the whole camera stack in general, and they've documented it really well. The WifiManager one's a little less documented, but also very useful. Yeah, so these are the links. So, armed with all this knowledge now, we're coming to the concrete example. This is now you know. Now you know about Wi-Fi, now you know about the stack. Now we're going to see where this was useful to me in our project. Let's go back to the drawing of what happens, just so that you're reminded. We've got the app from the phone connecting to the app on the car. The car starts an access point, right? So that's what it's doing. How is it doing that? Well, the OS, so Android Automotive OS, boots, and then Android Auto, the app, starts. So the process of it starts. And then Android Auto starts the access point in 5 gigahertz. And you'd say, well, story done, that should work, and everyone's happy. But it doesn't. So what happens? We call WifiManager on the car. We call WifiManager.start local only hotspot, which starts the access point in 5 gigahertz, which is what we want, almost always. Remember how I said 1 in 1,000 times, like it just wouldn't? And for most of it, we were like, this is fine. Like, I'm just sitting here rebooting the thing. It's OK that it's not starting. But it was almost always starting in 5 gigahertz. But very rarely, it was starting in 2.4 gigahertz. And at the scale of 1 million users, this was a big problem. So why? That's where the stack is useful. And that's why this whole talk. So our friend, first, the Wi-Fi driver. So the very lowest layer, remember, the Wi-Fi driver was ensuring that the hardware only operates within the country's legal limits. Well, what that means is, so what would happen is, if it wouldn't, essentially, if the driver wasn't loaded, it would just fall back and be like, hey, I don't know where we are. I would rather not start in 5 gigahertz. I'll just fall back to 2.4. That was like a very intentional choice that Android does, but that was a problem for us, because if it's not loaded, if it doesn't know what frequencies it's allowed, it would just start in one that we don't want. So what this meant was the Wi-Fi driver had to have been loaded once per boot. So then the question, how do you load the Wi-Fi driver? Very simple. You just turn the Wi-Fi on. So literally, that Wi-Fi toggle that you have, the station mode thing, you just turn that on. And then that loads the Wi-Fi driver. The problem is, just turning it on is not so simple. So there are problems, of course, like UX, where you see the flicker happen early at boot. Oh, let me just tell you, all of these problems, a lot of these were also because we were trying to start Android Auto as early as possible at boot. Of course, as soon as you enter your car, you want the thing to start working. But because we're touching so many of the system components which are also booting, a lot of these problems showed up. So back to just turn Wi-Fi on. That was a bit tricky, because Android, like I said, removed some APIs. So unless you're a part of the system, you have to ask user for consent to turn Wi-Fi on. And yeah, we had to get those permissions. So now what happens? OS boots, Android Auto app starts. Android Auto turns Wi-Fi on temporarily. And now, then Android Auto says, hey, OK, we're good. We can start the access point. And then I was like, yes, OK, this worked. And honestly, this took a while to figure out. Now it looks very nice over here, but it was like, OK, a big deal. We were trying to figure out what exactly is going wrong. And so we were like, yes, now this should work, right? No, it didn't. And we had more problems to figure out. So the next one is Wi-Fi concurrency. Remember that huge matrix that I showed you? That. So essentially, now we're at this point where the Wi-Fi driver is loaded, but the country code is not set. So now the driver is loaded, meaning it's turned on, but it doesn't know which country it is in, or it knows, but it's like still in the process of booting up, so it doesn't fully know. Essentially just a race condition. And then you had LTE plus AP concurrency issues, which simply means your 5G, the SIM card in the car, is also booting up at the same time you're trying to turn on access point. It messes up the frequencies that it chooses. And so these concurrency issues were a problem. So what we added then was another block, which is we check for frequencies supported by the OS. Now, the documentation here is a little confusing. There are two. So I don't know if you can see this because it's struck out. But WifiManager.get allowed channels. And what that means is, does the OS support 5 gigahertz generally? But what we wanted was not, does it support it generally? What we want is, does it support it right now? Which is where get usable channels is useful. So what you always want to know is, hey, the thing booted is 5 gigahertz supported right now. All right, so now we were like, OK, finally, now this should work. No, it still didn't work. What we had then was the final problem, which was WifiManager.get usable channels too early at boot, causing HAL crashes and problems just because of early boot. So we had basically a HAL crash. Remember that extra layer in between? You see a very nice line saying, hey, HAL gave up. So HAL crashed, and that was happening because we were touching Wi-Fi too early at boot. Again, this would not always happen. This would happen rarely. And so calling WifiManager.get usable channels too early at boot is causing problems. And so what was the solution? Just loop. So we just essentially, sure, the HAL crashed. OK, we just try it again. And it was as simple as that. And then we're like, now finally, this should work. All right? Yeah, it did. Yeah, so it finally did work. Very happy with that. And that's where then, essentially, I'm going to stop the loop. That's exactly where then knowing the stack has been useful. Again, you may or may not face this in your development. The Android APIs are very robust. But if you try to do things out of sequence, out of order, if you're making a custom ROM, if you're making, modifying AOS, which some of you, I presume, are, you're going to face some of these challenges. A lot of this was also then fixed, and this is the good, lucky part of being at Google, which is once you run into these issues, then they are fixed in the framework down below. So a lot of these problems you will not face with Android 15. It's just the car industry is a little slow, where it's always running a couple of years behind. So if you have the latest is at Android 16 now, the car manufacturing industry is still catching up with like Android 14. So it takes a while to show up. But if you do these on phones, you're not going to run into these issues anymore. So with all of this, thank you. That was my talk. I hope this was useful for all of you. Thank you so much.